So until here, we have understood that why there is a need of decision tree and what decision tree does, right? We need decision tree, okay, for non-linearly separable data, okay. And what decision tree does is it creates multiple decision boundaries based on multiple features in order to correctly classify the data in a correct class with less amount of impurities in it. Okay, so let us now understand that how exactly it works. ये जो feature selection हो रहा है या multiple decision boundary हम create कर रहे हैं, exactly हो कैसे रहा है, what is the mechanism, what is the working of this. Okay, let me give you one very straightforward example. All right, let us consider, guys, that there is a graph here. All right, there is a graph, there is a data given to us, and based on that data we have created this kind of a graph. Now, what does graph tells? This graph is a, let's say, movie review graph. Okay, there are a lot of movies. We have asked certain people to review them. Okay, in order to that we have created a particular data. Okay, there are many people of different age groups, both male and female. All right, so we have here two categories, we have two columns majorly. There is something, or you can say there is one column called as gender, and there is one column called as age. Right, there is two columns, there is gender column, there is age column. Okay, right. In gender we have two categories, male and we have female. Right. In gender we have two categories, that is male category and a female category. Okay, now when it comes to this review, okay, what does review is whether the person, regardless of male and female, whether the person has liked the movie or not. So by our data we have come to the conclusion that, okay, we have come to the conclusion that these people here, okay, now guys, circle represents like and cross represents dislike. Okay, I repeat, circle represents like the movie and cross represent dislike the movie. All right, so we have here people, we have all the males who have loved the movie, basically like the movie, so circle. Right, there are, let's say, let's give it a number, so we have six male over here and six, let's say, let's take six females as well. Okay, so there are females, so there are males who have liked the movie, but when it comes to female there are females who didn't like the movie. Okay, so we have some female who definitely who loved the movie, who liked the movie over here, and again there are some females who didn't like the movie. Okay, now you can relate with the previous example that why we require decision tree, right? Because we have not one, okay, but the mixture of data points in the same class, right? There are people in the female who like the movie and dislike the movie, whereas male is completely pure class. Okay, it has only one category, that is liked. Okay, but female has two categories in it, that is liked and disliked. Okay, let us also give some numbers for age as well. So let's say we have age 0. Okay, age 0, let's say age 20, age 40, age 60. So at the interval of 20 I have created some age range. Now at this particular data, guys, we can create multiple decision boundary. One decision boundary can be created like this, very straightforward on gender. Okay, one decision boundary can be created like this, right? One decision boundary can be created like this. We can create many decision boundary. Okay, but this is not the right thing. We need to understand that why we need the decision boundary and what exactly we want to understand from the data. The goal over here is, guys, given any movie, right, given any movie in the future, my model should be able to predict based on age, based on let's say gender of the person, whether the customer or whether the person will like the movie, upcoming movie, or not. That is what the goal of our, I mean, of this data set, let's say. Okay, so as I said, first what we will do is, it is very much straightforward, that if I create a decision boundary, right, if I create decision boundary based on the gender, so we will definitely will be able to evaluate that yes, if the person is male, he will 100% like the movie, right? Am I right? If the person is male, right, he will definitely like the movie, because it is very much clear, because there is no impurity in the male category. Okay, all the males have loved the movie. Okay, so let's create the tree now. As I said, if the person, okay, will first create a decision boundary based on gender, right, we will create a decision boundary based on gender. And as said, if the gender comes male, if the gender comes male, right, the user, or let's say the customer, will definitely like the movie. It's a yes. Okay, but again, if the gender is female, what if the gender is female, what to do? Now try to understand the how SV, I mean, decision tree works, guys. So we are here able to classify our data based on gender, that yes, if the gender is male, the person will definitely like the movie. But what if gender is female? Here in female category, there are mixture of both, yes and no, like and dislike. So in this case, decision tree algorithm will select the next feature, that is age. Decision tree algorithm will create one more decision boundary based on age feature. Now based on age column, decision tree will create one more decision boundary. Now if you notice this dotted decision boundary which is created by using the age column, right, people who have less than 20 years old dislike the movie, and people who are greater than 20 years old, for now let's suppose, if I consider these two people, if the age is greater than 20, then definitely they like the movie. So what I will do is, at first I will create a hyperplane, or you can say decision tree will create an hyperplane based on the gender, that yes, if the gender is male, they will like the movie, and if the gender is female, the algorithm will select the next feature as age. Okay, the next decision boundary will be created by using age feature. Okay, and what would be the parameters? Okay, there are two parameters over here. Again, less than 20 years. Okay, if the age is less than 20 years, guys, what should be the scenario? If the age is less than 20 years, they will definitely don't like the movie. Okay, they will don't like the movie, they will dislike the movie basically. But if the age is greater than 20 year, what next? I cannot say all the people who are above 20 they will like the movie, because there are two people here who have disliked the movie, right? I cannot say that if the age is greater than 20 they will also like the movie, because there are two people here who dislike the movie. So your decision tree algorithm will move ahead and select the next feature of same age column with some different margin, with some different value. Okay. So again, one more decision boundary will be created based on same age feature. Okay. So what we have done till here, if the gender is male, they will definitely like the movie. If the gender is female, we will decision tree algorithm will go ahead and check the age. Okay, if the age is less than 20, they will not like the movie. If the age is greater than 20, we will again create one more decision boundary based on age feature. Okay, and what that would be is, okay, so this is age less than 40 and greater than 40. So if the age is less than 40, all right, if the age is less than 40, definitely they will like the movie. It's a yes. And if the age is greater than 40, they will not like the movie. They will dislike the movie basically. So this is the way how decision tree works. Based on many scenarios, based on multiple scenarios, it will try to have a class with less number of impurities in it. Now if you understand this, guys, there is this region over here which has only x. There is no different category in it. Sorry, there is no data point from different category in it. If you consider this region, there is only 0. There is no x present in this particular region. Again, if you consider this particular region, there is only x. Okay, so all the regions are purely categorized now, right? All the regions are purely categorized. Okay, now as you can see this, try to also understand if a particular algorithm is able to classify the data so well, that leads to overfitting. Right, that leads to overfitting. So most of the time when you will implement a decision tree algorithm, okay, overfitting definitely happens in that scenario. Okay, you will definitely end up getting overfitted model because there is no impurity, there is no scope of error in the model. All the regions are perfectly pure, as you can see yourself, right? One more thing, guys, you need to also understand, when it comes to decision tree algorithm, okay, there is something called as root node or parent node, right? The root node is the node that contains all the data prior to splitting, right? The nodes are split by splitting criterion into two branches. अभी अगर आप देखो तो एज दो ब्रांचेस में स्प्लिट हुआ, जेंडर दो ब्रांचेस में स्प्लिट हुआ, मेल एंड फीमेल, right? So nodes are split by a splitting criterion into two branches, each of which leads to another node. When you split gender into male and female, there are two different nodes, yes node and node age. Okay. Further, the node age is divided into two more. Okay. So nodes that do not split any further called as leaf node. The node which are splitting ahead is called as decision node. Now, if you understand this terminology, the very first node here, this node, okay, is called as either root node, right? Is called as either root node or parent node. Okay. Then the node at this point, right? This node here, this yes, this no, then this yes, okay, this no, okay. The nodes which are not at all splitting ahead, okay, the nodes which are not at all splitting any further, these nodes are called as leaf nodes. Okay, the nodes which are not at all splitting ahead, these nodes are called as leaf nodes. Also, if you have nodes, okay, if you have nodes which is actually splitting ahead for further decision making process, these nodes are eventually known as decision node, right? These nodes are eventually known as decision nodes. So I repeat the statement. The node, the root node is the node that contains all the data prior to splitting. Okay, nodes uh, are splitting, or you can say nodes are split by a splitting criterion into two branches, each of which leads to another node. Nodes which do not split any further called as leaf node, and nodes which is used to, split or make any decision or split the nodes further is called as decision node. Okay, by this guys we can come up with this definition that decision tree is a tree where each node represents a feature, or you can say attribute. Okay, each link or branch represents a decision rule, and each leaf represents outcome, which can be categorical or continuous value. Right, so that is what decision tree is, which state the same previous definition that I had discussed with you, that decision tree is the arrangement of the data, right, in a tree structure where at each node data is separated into different branches according to the value of attribute at the node. Okay, so that is what decision tree is. Now I hope you all understood that how exactly decision tree works. In other words guys, decision tree is nothing but some kind of an if else structure. If this works, execute that. If that this doesn't work, select some other feature, some other column, some other attribute, and start splitting it ahead. Right, so it's kind of an if else. So if gender is male, the person will like the movie. If the gender is female, we will go ahead using different hyperplane, different feature, different column, that is age. Okay, so if the age is less than 20, the person will not like the movie. If the age is greater than 20, we will again select the age column. Okay, and if the age is less than 40, the person will like the movie, and if the age is greater than 40, the person will do not like the movie. So we can actually make this tree diagram using if else also. Right, using if else also. So decision tree is kind of a combination of if and else, or nested if statements. Is that clear till here? Did you all understood that how exactly decision tree works, guys?